All right. Hello, folks. Welcome. I'm looking to the audio-visual people in the back. We got audio coming through okay. Thumbs up would be good. All right, fantastic. Well, welcome, folks that are joining us online. I see the numbers ticking up as we speak. For individuals to join us, as you hopefully are seeing on your screen, for the harmful algal bloom forecast for 2025. And I was just told it's Rick 14th year. Fantastic. Webinar is recorded, so if you want to come back to it later for anything that's in here, or if you hear content today that you feel like your colleagues should have, we will have that recording up on the website for you to distribute however you want. So those of you that are online, we've done this now. You know, we're all experts post-COVID, but if you're having any trouble with your audio, look in your bottom, depending on your computer, it'll probably be in the bottom left. There's an audio a microphone down there or a video button. If you're not seeing our screen or if you're not hearing us, that's your solution. You're going to want to go to that audio and video button. You'll see that there is a chat function also on the bottom of the screen for the webinar. So those of you that are joining us virtually, that's where you'll submit your questions. This event is here to, again, convey nutrients in the lake as of today and the forecast for HABs going forward. But we want to answer any questions you have about anything related to, the bloom nutrients. So please put your questions in that chat function. If you are a media representative, please indicate that in your Q&A, because we know a lot of great media folks in the region want to get stories out on this. And so we want to make sure those questions are answered so that we can get those covered in the stories that you're putting out. We will have a lot more, if history repeats itself, we will have more questions than we can get to today. And so I will try and combine those, try and hit ones that bubble up as questions I often hear, so clearly they need to be addressed. So I apologize in advance if we don't get to all the questions that are asked in that chat function, but we will do our best. I'd like to highlight the agenda before we get into recognizing some of the folks that are in the room. We had some phenomenal folks travel out here for us to get 2 boat rides. And a tram to get here. I promised them air conditioning. That's where we're at now. So that's phenomenal. So as soon as I'm done with introductions of folks in the room and having folks that we have a lot of representatives from state and federal offices here, just to have them stand up and recognize yourself. The microphone is up here. So when I call you, if you want to come up, I will hand you a microphone. If you don't want to say any remarks, please, that's fine too. So the speakers today, we'll start right off with Dr. Nate Manning. So Nate is the interim director of the National Center for Water Quality Research at Heidelberg University. And if you've been a member of these forecasts before or attendee of these forecasts before, he's going to give you the Maumee River loading. So he's going to tell you basically what was happening since the 1st of March to, we say, the end of July. But actually, we're not there yet, folks, right? So we're going to have close to the end of June. And then Dr. Rick Stump is going to coming to us, NOAA, NCOS, so the National Center for Coastal Ocean Science. He's going to give you the 2025 forecast. So he's going to take the data that comes from Nate, and he's going to highlight some of the models that NOAA and NCOS use to generate a forecast for this year. After those 2 speakers, we will pause for questions. Again, that's what the purpose of this event, the primary purpose, is to give you those bloom loadings and the bloom forecast. So we'll pause there for some questions online. When those questions start to decrease in their volume coming in, we will then switch to bring on a speaker for you. What we do every year is not only give you the forecast, but we try and talk to you about some cool research that is coming out related to harmful algal blooms that we feel you need to be aware of. And so today it's our pleasure to have Dr. David Kennedy from the University of Toledo. He's an associate professor of medicine. He's really going to talk to you, and I don't want to butcher the title, but really talk about we know these are called harmful algal blooms. That H is because they have the ability to produce toxins. Dr. Kennedy and his lab and his colleagues have been doing a lot of work to see what are those impacts of those toxins on the populations that live and recreate on that lake. So that's your lineup. You're going to see your nutrient load, then you're going to see the forecast projection, and then we're going to talk a little about the impacts of the toxins on human health. So in the room, as usual, again, those of you that have been on one of the previous 14 events, we have a lot of academics in this room from multiple universities across the state. We do not have time to introduce all of them, even from our Canadian counterpart. So we have researchers from University of Windsor here with us today. But they're here not only because they contribute a lot to the work that's going on for Rick and Nate and Dr. Kennedy, but also they'll be able to answer some of the questions that maybe our speakers are not able to answer. So we make sure that we bring a lot of academics from across the region into the room for us today. We also have both state and federal agencies that are in the room. And so I just want to thank them for joining. Also, what we've learned since the 2014 Toledo Drinking Water Advisory is that the solutions that need to roll out to address harmful algal blooms is not going to take one agency, and it's not going to take one academic and university. This is an all hands on deck. Federal and state elected folks, federal and state agencies, and all the academic power we have across the states. And so it's great to see those agencies, again, both state and federal in the room. And again, thank you for our academic partners. So we also have, as I mentioned, numerous state and federal legislative aides in the room, and we actually have Senator Paula Hicks Hudson in the room in person. So thank you for that. But I'm just going to run down, and again, I'll call your name out. If you just want to wave your hand from your seat, I'll acknowledge you here. If you want to say words, just come on up to the podium. But we do have representation from Senator Bernie Moreno's office. So Tim Schneider's in the room. Tim, any words you want to say? Yeah. Oh, you had to step up phone call. That's what our legislative elected bag's right there. I see the bag. So we'll come back. From Senator John Husted's office, we have Ashley Ashton and Lori Brody waving their hands. Good. There's Tim. Tim, did you want to make any remarks from Moreno's office, or just a little wait? Come on up. Anything you want to say? Good. Oh, good. Here we go. Everybody from Senator Bernie Moreno's office, Tim Schneider.
Thanks, Chris. So, hi, everybody. So I'm Tim Schneider, the Regional Director for U.S. Senator Bernie Moreno. What's probably of note is the Senator co-chairs the Senate Great Lakes Task Force. And so he will have a purview on federal issues related to the Great Lakes. I previously worked for Senator J.D. Vance before he ascended, and he likewise co-chaired the Senate Great Lakes Task Force. So the senator will be have this leadership role on issues impacting our lake. And so we look forward to future opportunities to work together with the research institutions here in Northwest Ohio, and the others are taking the lead on these issues. I also bring with me a proclamation from Senator Moreno. And I guess if you wanted to hand that off. All right. So the senator wanted to use this opportunity to recognize Stone Lab on your 100th anniversary of being located here on Gibraltar Island. And so this location has served as a pretty important geographic place to study lake issues and engagement on harmful algal bloom issues, invasive species, things like that. So we really appreciate all the great work that this institution has done over the years. So congratulations to you on your 100th.
Thank you very much.
Yep, you bet.
Thanks for that, Tim. Ashley and Lori, coming back to you. Still just a wave. We're good. There, we love it. Good. And they have huge smiles on their face, and they're happy. And happy birthday. Thank you. Good. Excellent. Representative Bob Latta, we have David Wirt in the room. Dave, nice hearty handshake there. Great. Representative Max Miller's office. So we have Jeff King and Elizabeth Sahar there, and a wave from their seats. Thank you. Great. And then from Senator Rob McCauley's office, we have Luann Cook. Homecoming Queen wave. Good. And then we have Senator, as I mentioned, Senator Paula Hicks Hudson. Any words you want to make? Please come on up.
I'm really honored to be here, and I'm not sure how many years I've known you, Chris, but it's been since I first of all want to thank you for not saying that it was a water crisis in Toledo, but that
drinking water
it was,
advisory.
Thank you very much, because that's so. Well, what has happened because of that is that there's been a collaboration, and it has been between all of the universities that are in the great state of Ohio, as well as our partnership with our friends across the pond and in Canada. And I am pleased to be a part of this and to continue the fight for us here in Northwest Ohio to make sure that we are very clear about our mission to heal the lake. And so whatever I can do and continue to do to fight for those things, not only the resource, the information, and to share the good work that you're doing, all you got to do is call me. And as I said, I showed up.
Thank you very much, Senator. All right, with that, I'm looking back at the IT to make sure everything's going all right. Audio's good, fantastic. All right, I'm going to switch our slides. Look at me juggling things. All right, 1 second, folks online. We are going to pull up another PowerPoint here, and we'll get going. Sorry for the delay, folks. 1 second. You'd think I'd have this figured out by now, but apparently not. Sorry again. 1 second, folks. All right. So as promised, the first up will be Dr. Nathan Manning, also again presenting on the nutrient loading to the Maumee of the Maumee River. And let me make sure back on the screen and we're seeing what we need to see. Nope. Okay. 1 second, folks. Little glitches, tiny glitches occasionally. Yeah. How about now? Okay, got a thumbs up, and the floor is yours, Nate.
All right.
Sorry.
Got it?
Yep.
Okay. All right. Great. Thanks everybody for being here in person and those of you online. I'd like to start off thanking Dr. Winslow and Ohio Sea Grant for all of their logistics and organization, not just for this this presentation, but all of the work that's being done across the Great Lakes. Your award at IAGLR was very well deserved. And Dr. Rick Stumpf and all of the people at NOAA that do really the heavy lifting when it comes to the analysis and putting out the actual forecast. My name is Nate Manning. I am the interim director of the National Center for Water Quality Research at Heidelberg University down in Tiffin, Ohio. And today I'm going to be talking to you about the Maumee River. Okay. There it is, highlighted there with the red dots. Use my laser pointer for that. And why do we care about the Maumee? Right? Well, the Maumee only contributes about 5% of the water that enters Lake Erie. It's contributing about half of the nutrient load and sediment that gets into the lake, right? And so you can see at the top here, the Maumee River loads similar to the Detroit, but the Detroit is an order of magnitude higher in terms of water volume. And so what's coming out of the Maumee is very concentrated. And that's really important to the harmful algal blooms and their progression.
You're taller than me, so your head's
Oh.
being cut off. So let's.
Okay.
No, yay.
Not just my neck. All right. And so the Maumee is really important when it comes to these harmful algal blooms and their progression. So our program at the National Center for Water Quality Research, the Heidelberg Tributary Loading Program, supported by state funds through Ohio Department of Agriculture. We've been operating for about 50 years now, right? And we have a really amazing long-term data set, daily data for the Maumee going back to the 1970s, right? We don't just monitor the Maumee. As you can see, we monitor 16 different locations around the western basin of Lake Erie, 23 in total in Ohio and Southeast Michigan. But today, we're going to be focused on the Maumee and particularly the data that comes from our station here at Waterville in Ohio. So how we do this, at our locations, we have a sampling station. We're generally piggybacked on the back of a USGS gauging station. Within that building, right? If you drive by a river and you see a little shack next to the river, it's often a USGS gauging station. In those, we'll have an automated sampler that collects samples 3 times a day. And you can see, right, storm came through and we've got clear samples and then muddy samples from the storm. We go out sort of like the Postal Service, rain, sun, shine, snow. We're collecting samples every week and bringing them back to our lab for analysis, right? So in our lab, we do total fractions, we do particulates, we do the dissolved, all in-house, colorimetry, ion chromatography. And from all of that, lots and lots of samples from lots and lots of places, throughout the year, we get lots and lots of data. Right, and this is the data that I'm going to be talking to you about. And because we do such high frequency sampling, we can see changes that happen in the river very quickly. So quickly, a couple of things, some terms that I want to make sure that everybody is on board with. When I talk about total phosphorus, TP, total phosphorus here on the left is the combination of the dissolved phosphorus, so everything that can pass through the filter that we use, as well as the particulates, right? The stuff that gets caught in those filters. And then when we talk about total bioavailable phosphorus, or TBP, right? TBP is some combination, right, of that dissolved fraction, as well as some of the particulates, right? And it's basically the particulate phosphorus that doesn't settle out between Waterville and the mouth of the river into Maumee Bay, right? And it's about 8%. Figure about 8% of that particulate phosphorus is being transported to the lake and can be bioavailable for the harmful algal blooms. And so when I talk about TBP, it's mostly the dissolved reactive phosphorus, but it is about 8% of that particulate as well. Okay, so what does the Maumee look like? This is from March 1st to June 16th, the last day that we have official data for. What we saw is the discharge here. Discharge was highest in April, but we did get some significant storms in May and a couple here at the early part of June. But what we can see is that the highest discharge events definitely occurred in April. But May did contribute, in contrast to what we saw last year in 2024, where most of the loading was driven by just April storms. May and June were very low when it comes to discharge. We can see when we look concentrations, these little red dots here peak following storm events, right? Storm event, and then there's a peak in concentration, and they follow along like that. We then take that, it's a little hard to see here, but there's little black dots here. These are the loads, right? When we multiply the concentration, right, by the amount of water coming out, right, we get the load, the total amount, essentially the mass of phosphorus, nitrogen, sediment. And then what we do is called a cumulative load, and that's this red line here, right? And we can see that we're sort of adding up all of these little black dots, right, as we go through, and we see a big storm drives that cumulative load higher, right? And then it dries out and it flattens out. So that cumulative load is important because it's telling us just how much phosphorus and nitrogen and sediment is getting into the lake and at what time of the year, what month of the year it's coming in. We saw about 50% of the load so far this year was delivered in April, and about 30% occurred in May. And so if we just look at that cumulative load, right, here's where we are right now. Well, here's where we were on June 16th. We're about 227 metric tons, right? And if we project out using data from National Weather Service's Ohio River Forecast Center, based on their predictions for what's going to happen between now and the end of July, we expect there to be between 235 and 273 metric tons of phosphorus being delivered to the western basin of Lake Erie by the end of July. Note the target. The Annex 4 target for dissolved reactive phosphorus is 240 metric tons, right? So there's a good chance, right, that we will stay below or right at that target, which is good news. Comparing that, what we're seeing this year to what we've seen in previous years, right? So the minimum, this I believe is 2012, the maximum 2015, right? And then I've added a couple other years here, 2022, and then last year. We're in the similar sort of range, but you can see, right, that we sort of got there in different ways, right? In 2024, it was all this April loading, and then it flattened out, right? In 2022, not much until May, right? And then May through June, it crept up. And what we're seeing now in 2025, a strong May or a strong April surge, a little bit in May, and it's been very flat since then. So looking at what we're seeing over time, right? So I'm going to show you some plots that look like this. Each one of these blue bars represents about a 5-year window, except for the first one, that's actually 7 years, 82 to 89, just so we can make it nice and even. The blue bar shows the average value of that time period. And then each of these dots here, right, is an individual year. Right? And so we can see in the 2020s, right, most of them are sort of clustered right here around the average, whereas in the 2015 to 2020 range, right, we had a much larger spread, right? 2019 up here, very, very high, whereas, you know, some of the other years were low, but it still ends up with a high average. So when we look at these specifically, what do we look like in 2025? The red dots here are the values that we've seen as of June 16th. For discharge, we're right at that, just about at that 5-year average. Right? We've seen about 728 billion gallons come through Waterville. The average, long-term average, about 778. Just since 2008, it's about 899 billion gallons. So we're down when we look at just sort of the last 15 years, right? But a lot of that's being driven by what we saw in 2015 through 2020. But if we look at back sort of the entire period of record, we're right about the average. When we look at the total particulate phosphorus, again, this is one component of that total bioavailable phosphorus. Again, we're slightly higher than our 5-year average, around 1,100 metric tons as of June 16th of particulate phosphorus. Based on the amount of flow that we've seen, we would expect about 847. So we're a little higher than what we would expect just based on flow, and higher than the target for that at 674 metric tons. Dissolved reactive phosphorus, on the other hand, the one that's the majority component of total bioavailable phosphorus, we can see that as of June 16th, we're at 148 metric tons, right, of dissolved reactive phosphorus. Expected based on our flow is 205, right? So we're below where we would expect just based on the amount of water, right? And the target's 186, right? So we're below target. And this is the first time in the last, 5 to 10 years that we've been below target on DRP. And we're seeing levels sort of pre-2000 with DRP. Yes.
Hey, Dave, just a quick clarification.
Yep.
The averages and the targets, are
Yep.
those cumulative for the season or
Yes.
through June 16th?
They're cumulative for the season.
Okay,
Right.
so that's why like the water flow, 728 billion.
Right.
It's reasonable to think it'll end up around 778.
It'll be right about where we expected.
Okay.
Yeah.
Hey, could you repeat that question to folks online? I don't-
Yeah, sorry. It was just a question about whether or not these averages here are cumulative as of June 16th or through the end of July, and they're through the end of July. But when we say the expected here in these, that's expected through that date, through June 16th. Right. So we are below target for DRP. We're above target for particulates. Another way to look at this is the concentration, right? At the beginning, I talked about how the Maumee is really concentrated, and that makes it different from the Detroit River, right? About the same amount of load comes out of those two rivers, but the Maumee is much more concentrated, and that's an important point to make. When we look at concentrations, again, the particulates, we're sort of at that 5-year average, about 0.4 milligrams per liter. The target is 1.8. So we are above target again in concentration for total particulate phosphorus. But when we look at dissolved reactive phosphorus, right, we're right at the target, 0.054. The target's 0.050. And so we're seeing progress, right? Particularly in the concentrations. And this is the flow weighted mean concentration, essentially taking out the effect of how much water is moving through. It's just, what is that baseline essentially concentration? And so, we can see this is the lowest concentration that we've seen, really since before 2000. And this is really great news for progress being made on dissolved reactive phosphorus in Ohio. I've talked about, at the bottom there, based on the amount of flow that we see, where do we expect these to be? I'm going to show you a couple of slides here to just sort of better illustrate how we do this, right? And so when we look at the loads right here on the y-axis versus the discharge, we get a really nice relationship, right? The more discharge you have, the more load you have. The more water there is, the more nutrients that can be carried by that water. And so when we look at total particulate phosphorus and dissolved reactive phosphorus, right, we get the same relationship. And we can see, right, low years down here, 2012, 2005, and then our high years, 2011 and 2015, right? They sort of bracket this relationship. And, it holds across all the years that we've looked at. And again, just a reminder, right, total bioavailable phosphorus, this one here on the right, right, is about 8% of the total particulate phosphorus plus all of the dissolved reactive phosphorus that we see. And so now when we look at 2025, right, our particulate phosphorus, it's higher than where we would expect just based on flow, right? So we are getting more particulates, more sediment, and more phosphorus tied to that sediment. But when we look at dissolved reactive phosphorus, we're quite a bit lower than where we would expect based on flow. And this is a good thing, right? This is encouraging. And then when we look at total bioavailable phosphorus, we are still below target on that, basically right at that expected line. And again, remember, it's 10% of this plus all of this gives us this value here, right? And so we're doing well with the total bioavailable and dissolved reactive phosphorus based on what we've seen coming out of the Maumee. So in conclusion, April and May both contributed to the cumulative loads in 2025 in contrast to 2024. Total particulate phosphorus is above target and loads and concentrations are both above that or at that 5-year average and are similar to numbers that we were seeing 2010 to 2015. DRP and TBP, however, the ones that we're really sort of more focused on when it comes to the harmful algal blooms, the loads and concentrations are at or below that target, right? Even with the increased discharge that we're seeing in 2025 compared to 2020 through 2024. So it has rained more this year than it did last year, but our loads and our concentrations are lower than what we saw last year. So based on the 2002 through 2018 relationships that I showed you there of load and flow, DRP and total bioavailable phosphorus are lower than we expected. And that's a good thing, good news. TPP is higher than expected. This is likely due to that April high discharge, right? The storms in April that came early in the season, pre-planting, and allowed more sediment to come off of the fields than would happen, later in the season now until the end of July, where the plants, the corn and the soybean and everything is already on the fields and helps retain some of that. So concentrations, in conclusion here, concentrations of DRP and TBP are continuing to decrease, right? We've seen a pattern over the last 5 years of decreasing DRP and total bioavailable phosphorus, and they're continuing to decrease even when we correct for the amount of water that's coming out of the Maumee. Thank you, and we'll take some questions later after Rick.
Yeah, after Rick. Yep, great.
Thank
Thank you, Nate. Thank you very much, Nate. That was great. I'm going to stop sharing here, folks, and then we will put up Rick Stumps. And again, after Rick is done with the forecast, we will then open up the floor for media questions first, and then we will field all other questions. That is not, yeah, as folks point out, that was not Gibraltar Island in the background, although it's gorgeous, Before I get to Rick, I just want to make a misstep on my part in the beginning. We also have no representative from NCOS in the room. So Sean Corson is in the room. Sean is the director of NCOS. So the lab that Rick works for is here present to watch the presentations too. Great. How are we looking back there, Alex? We have the right screen up. We're good to go. Yep, good to go. All yours. Project if you can. There's a microphone. Everybody, Dr. Rick Stump, his 15th year here. This is fantastic. Yes. Good.
Great, thank you. Thank you so much. Thank you so much, Chris. Ohio State Grant, Stone Lab, that's a huge amount of help to get the information and get people here together. And thank you, Nate, for coming and capturing that. I can't emphasize enough the value of Heidelberg's work with the National Center, because having that kind of data on the nutrient loads makes it possible to actually understand what's going on here. We wouldn't be able to do that otherwise. The photo in the background is Gibraltar Island, by the way, in this case. And and yes, it's a pretty place, and this is location being right in the middle of the lake, you really know what's going on, capturing that. So with our forecast, we work with colleagues who have other models, those at Carnegie and Stanford, also University of Michigan, North Carolina State University. And we also work closely with our Weather Service, Ohio River Forecast Center, as far as determining what the flows actually are or will be going forward, to understand that. So let me continue on. So, well, been here for 14 years. We have been, one wonderful thing, we work with satellite data to monitor the bloom. And a great thing about it is satellite produces kind of a virtual time machine. So there's data going back to 2000. And so we've been able to assess the blooms over that time period. This is a snapshot of the peak of the bloom each year from actually 2002. 2000 and 2001, there was basically almost nothing in the lake. From Lake Erie in the 70s and early 80s, when there was extensive blooms and people declared Lake Erie dead, it recovered because of the Clean Water Act significantly, the phosphate ban in detergents and the like. And then, but now we've seen this reappearance of this that has to do with a lot of things that you can talk to the agriculture people about. Mark Smith, I think NCRS is here as to what's going on. But you can see how much the bloom varies between years. 2011 and 15, which were, let's see if I can point them with the laser. Don't have a laser pointer.
Let me turn it up for you if it's not on.
Ah, now it is.
There you go.
Okay, so 2011, 2015 do stand out as larger ones, and you can see though how very different they were at their peak. Emphasize this did not look this way in there all the time. 2011 were well past Cleveland, and that was in early October actually. It carried out that far. Other years it varies a lot, both in intensity and in location. We hear a lot about 2014. 2014 was very intense locally, and it was also a very early bloom at the time. That was part of the issue. It was surprisingly early for the intensity. So just because it's huge doesn't matter. I will note 2017 was exceptional one because there was scum in the lake from downtown Toledo across to Leamington, Ontario, literally in September. And that was an exceptional one. But you see that just very localized bloom. The other part on this is when we started, we were using MARIS, European Space Agency satellite, which unfortunately was lost in early 2012. Its successor, ULCI, was not scheduled for launch. That actually went up to 2016. We're able to fit in with a NASA sensor, MODIS, to capture in between. We did a lot of processing in 2016, just before ULCI, and we've now actually done an update. But the great thing on ULCI is there are two up now. The next two are scheduled for 2026 and 2028. The long-term time series with the same instrument going forward for the next several decades, which is really great because this is a very high-quality instrument, well suited for finding cyanobacteria, I should add, specifically. This year, we did a reprocessing of all our data to make sure it's all consistent with ULCI. So ULCI is our standard. The MODIS, we had done some, we had some challenges. We found some errors in the data. There are also gaps with the MARIS time series because it's less frequent. So we're able to fill all those in, and we changed that. We have a severity index, and in this reprocessing to match it, what we found, the previous time series are the black dots, the new severity index now, we better capture 2003 to 2011 with this new time series. And the relative intensity of those blooms to the recent ones increased. So if you notice on the original, as we had this, these blooms were about the same scale as here. They're now higher than the current blooms. Everything scaled for 2011 as being the worst bloom. You would have heard me say last year that 2015 was in fact a little worse than 2011. In the course of reprocessing, 2011 is in fact the most severe bloom that we've had. That scaled to a 10, everything else is scaled to it. So that shift, the amount of biomass, this is a little subtle, didn't change for the recent years. It's the relative severity. And this actually makes more sense. For those of you who've been on the lake for years, if you think of 2008, 9, and 10, there was scums all over in the Western Basin, and that did not look like it did in the last few years. So this really makes a lot more sense. We do any future reprocessing, it's not going to change anything like this. Anything from here on will be very subtle as far as any differences. And a key part of that is it's getting everything consistent with the Olchi data set overall. So that's the key part in this, that we're looking at. Those earlier ones were more severe than they are now. So this is where we are going forward on the blooms. I had a webinar on this. For those online can usually get the QR code, but you can easily track that down by the Ohio Sea Grant webinar site if you want, if you did not see that, want more information on that reprocess. So just to recap last year's bloom, the 2024 was 13th year of the forecast. And we had a forecast severity between about 2022, 2023, and you can see that it was pretty much similar to the 2022 bloom, a moderate severity of 4 under the current assessment. And just to put a context, I would note how two blooms of about the same size and at their peak, how very different they were. This was very packed into just outside of Maumee Bay in 2022. And this was an area of scum, a lot more offshore. By the way, Nada commented about the Detroit River has about an order of magnitude more flow than the Maumee. And this is actually the plume of the Detroit River. So the reason there isn't anything in there is because the water there is fairly low nutrient, and so the bloom goes around it. And in this case, you get southwest winds, then it will often push it up to the Ontario coast. In this case, it was more northerly winds that kind of left it in this direction, but you can see how different they can be. And again, those peaks were very different. You saw similar from 8, but just to bring it back to where we are now. So 2025, we're looking at total bioavailable phosphorus around 230, 240 metric tons. And that's a bit lower than 2024 overall. And you might ask, well, how confident are we on that forecast going forward? What we're looking at is fairly normal temperatures for over the next month, fairly normal precipitation. And average precipitation is, you have a lot lower flows in general, where there's no weather patterns that are indicating high flow. So if it does rain, that's not going to change our forecast. That's an important statement. That rain in July is typical. Corn's in, and by the way, corn evapotranspiration, a lot of water leaves from the corn as well when it's in forward growth, which it happens in July. So we're looking at pretty normal precipitation and the resulting flows. So when we do the forecast, we do an ensemble of models. And that's a model we have, also the University of Michigan NC State model and Carnegie Stanford model. For those who are interested in the science and terms, I'd be happy to talk about those later or direct you to it. Probably many people in the room probably see some of the terms of Bayesian and so forth and go, please don't go into it in detail. So I won't do that. But what happens is there's some different assumptions and different characteristics. And so when you can't capture everything about a system, it's good to have different models, so you're bracketing the answer. That's the direction we try to go to. So where we are in the forecast, this year, we expect, we're looking at a 3, which puts us right on the border between a mild and a moderate bloom, and a potential uncertainty of between 2 and 4. And so this puts us probably potentially a little less of a bloom than last year, and similar, somewhere in the neighborhood between 2023, 2022. A key part, the uncertainty, the bulk of the variation in the bloom is due to the bioavailable phosphorus coming from the Maumee River over the spring. But that is not the only factor, and that's where we're now starting to work on identifying that. There's a little bit of internal load component of phosphorus. There's also how much of the phosphorus in the Maumee River gets used or tapped, and so there's potential competition from like the spring bloom, which right now we actually still have. We're at the very end of the spring bloom right now in this part of Lake Erie. Diatoms and green algae, the good stuff that people talk about as the base of the food chain. We're right there right now. And so those are little adjustments on that. What we're doing, we're starting to work through and to pin those down. It's very tempting to say it's as simple as, well, the lake's getting warmer, so it will change, but that's not how this works. It's not that simple. So we are looking at those, and in the course of modeling that, there's also some work going on in ecological numerical models that can help feed those assumptions into other approaches, and there's some other groups working on that. So that's the effort to try to get those down very well. This forecast is on, we're around the near average TPB loads through the spring so far, March to June, and that'll pretty much stay through July. And we're accounting for normal July rainfall. There's only a very small risk of any excessive rainfall in July. If you get a thunderstorm that happens to produce a ½ inch of rain or something, that's not going to change the forecast. We're going to have something much bigger, which is not expected this year. Again, the peak severity between 2023 and 2024, and just to show you how different, 2023 was a smaller bloom than 2024. It was in the mild range, and you can see those differences. There would have been little pockets. Some of these areas where the satellite shows it as an orange-red, those tend to produce scums. This is relatively small. I realize if you're out in a boat, a patch that's 1 kilometer is enormous, but on the overall scheme, these are pretty small and short-lived. This was a short-lived, very large one, but you can see how very different they are in the distribution for those. We have satellite imagery. It's at least through, this was particularly clear, but through yesterday, we have not detected a bloom yet in the area so far. I understand from Justin, who's in the room, he just saw a little ways from here, a little bit of microcystis present. I took a sample yesterday. There's no microcystis in the harbor here right now. Some last of the greens and diatoms and some very fat zooplankton who've been busy eating them. So right now it's calm, but we continue that monitoring. That's on our page. As far as the water, you're probably wondering about what's been happening with the water temperature. Right now, it's through last week, we were running this line here, just near average, a little below average. Last year was quite warm. That's actually this red line. You can see how much dramatically warmer last year was. This year, we were a little cooler. And just to show 2024 on June 20th, Western Lake was around mid 70 degrees. And this year on June 20th, we were down at mid 60s, quite a bit colder. However, as people in Ohio have noticed, anyone in the East Coast, it's been kind of warm in the last few days. And I've been checking the temperature, and it's literally been going up 1 degree Fahrenheit each day since June 20th. So lake's warming up really fast right now. And so I would not be surprised to see, we've been seeing the bloom start around the early July in the last few years, the first week in July. This will probably get it caught up. So probably another week, I would say by July 10th, there should be something noticeable, but it won't be the whole lake. I can't emphasize enough. It doesn't suddenly appear as this huge blob that eats Western Basin. It starts smaller, and it's really important to track that. Nate talked a bit on the discharge and the loads, and I at least want to touch on that. On the top ones are severity metric, and you of course notice that it's higher over this 2008 to 15 than it has been recently. And that's a great thing to see. But I'd like to note that the discharge, the total, just the volume of water, the discharge, coming out the Maumee River was higher at that time than now. So the blooms now are less severe than they were during that 2008 to 15. Most of this difference is caused by less river flow, simply less water carrying stuff into the lake. Most of it is caused by that. But the bioavailable has decreased somewhat. So part of this is that about 5 to 10% decrease in the, particularly the dissolved reactive phosphorus, which is completely available. They use that up. And so that is progress, but very important to keep in mind that if we get wet springs next year, there will be more bloom, because if we declare that we have solved this because they're small now, no, we're in the right progress on reducing the phosphorus, but we can't control the rain and the runoff. And so we have to keep making progress on getting the phosphorus down if we want to keep these small blooms occurring. We do a daily forecast of, we report where it is, where it's going. We also say at least the likelihood of scum being present, which is useful for boaters or for also the water treatment plants. You can get that pretty easily at coastalscience.noaa.gov. And you can also subscribe to our bulletin as well. And we have links to other places for information to GLERL, their sampling system, and as well as other state and other resources. So you can, we try to make it as much of a one-stop. You get there and you can find something else that you need to find. So wrapping up with a forecast, likely this year's 3, right on that border between a mild and a moderate bloom. And start in July, probably the first half of July, as in recent years. It'll likely peak in August, which again, that's what we've been seeing for the last few years. And this bloom will be should be confined pretty much to the Western Basin. It'll continue probably, our current best guess is it may continue well into September. But we don't have any particularly good skill on how long the bloom will last. That is another topic we're working on, because that gets a big question of when's it can end, when's it can end. And that depends on the fronts coming through in September as to when it does. So we've been testing some of the longer models that we have that go out about a month and a half, and we're hoping to get progress there. Areas with high concentration have the highest risk of scum, and I can't emphasize enough. Please keep your pets, keep your dogs out of scum, keep your kids out of scum, keep yourself out. We don't need anything bad to happen to anybody as well. And again, the bloom is not everywhere when it occurs. That's often an impression. It moves around a lot with the wind. It can be in the middle of the lake, it can be pushed to Ohio, and then a few days later be pushed towards Michigan and then pushed back around. It moves around a lot. So please, please check our forecast. We're trying to let you know so you can vote well. And that's wraps that up. Thank you very much.
Thanks, Rick. Rick, if you want to stick around up here, and Nate, if you want to come up, we'll hand the microphone back and forth and make sure folks that we're projecting. As predicted, there are like 40 questions here. So we're going to work our way through as many of these as we can. I am going to concentrate on the ones that we've had submitted either when folks registered or in real time from the media first. And so we're going to go down that route and then we'll start spreading it. For agency and academics in the room, the 3 of us are not going to be able to answer all of these questions. So if it relates to the work you do, please come on, bring your way up to the podium. This is always an all hands on deck kind of thing. So perhaps not a surprise, but there are 2 questions. One's coming from Danny Eldridge with the Hannah News Service and Tom Jackson from the Sandusky Register. But the question is, how will state budget cuts to H2 Ohio impact the state's ability to address HAPs? I'll take a crack at that, but I'll tell you out of the gates, the question is, it's going to have to be to be determined, right? The great news, although the battle isn't over, we have not won this. We are seeing numbers that I would say since about 2020-ish, when we say that 5 to 10% of the reduction in that DRP, let me see if I can get that back up here. That's where you're seeing that success. So although, you know, the flow drives most of those phosphorus in the water, we are now able to do different calculations and mathematical algorithms to see that there is actually a decrease in that dissolvable reactive phosphorus. So if you look at H2O Ohio and things like the DNR program, saw a little bit of a reduction in there. So the wetlands we were putting out, there will probably be fewer wetlands that are out there. What was being allocated through the Department of Ag and going to help our farmers put practices on the grounds, those funds are still there. They're not exactly where they were before. Increased, that's right. Thank you for that, because that budget came out yesterday morning. Correct? Yes, good. Thank you, Senator. So we'll have to see on these things, right? And so what we need to do now is we've seen success, and we would say H2 Ohio rolled out in 2019. You could argue the practices in the field probably did not start hitting the fields until 2021, 2022. So we had a lag in the placement of those things. But correlation does not mean causation. So we can't say that the success we're seeing now is wholly because of H2 Ohio. There are other things going on out there. So we're going to have to see what happens in the next handful of years. And are we seeing this reduction in DRP continue through time? Any other thoughts from Nate or from Rick in the room?
I would say that, you know, particularly the agricultural practices being put in place in the Maumee, you know, again, like Chris said, you know, correlation does not equal causation, but, you know, we see, you know, what we can attribute to best management practices, what we can attribute to, you know, changes in application of fertilizer, and then the construction of these wetlands, right? They're sort of following hand in hand. And if we can keep these processes going, if we can keep putting more and more practices into the Maumee, we expect to see better and better results, you know, in the future. And if we want to get to that 40% reduction, right, we need to keep increasing, you know, application of best management practices, education for farmers. That's a big part of H2 Ohio, and I think has really been one of the biggest sort of success stories of that.
I'd agree. Thanks, Nate, for that. Please.
So if you have increased in funding for that data to collect, like you're saying that, you know, you're expecting to see a decrease or, you know, to get better. But if there's lack of funding, how will you know that those predictions are actually representative of what's happening?
Yep. So the question for those that are online, it's if you're seeing reduced funding also in the groups that do the data collection and the monitoring, will you be able to capture any changes in time? I can tell you that working with the state and federal agencies and the academic partners, we are a very creative bunch, and we are trying to get to places as frequently as we can, as budgets allow. You know, you start thinking about, you know, sharing samples. If one boat's out in one place, can you grab samples and split it for other groups? So we are trying our best to do that and to be able to continue the rigorous data collection we have now. But a lot is TBD. So, you know, this is what we love to do as academics and agencies. You know, this isn't just a job because we want a paycheck. The people I get to work with love what we're doing, love working on Lake Erie, love monitoring the lake, love tracking progress. And so we're going to do our best to get out there. But it is a great question. Yes.
The soil sampling, how much does that play in? Because your sampling is mostly water, correct?
Correct. Yeah, we do some.
Let me repeat that for you, Nate, and then come back up. So the question from Luann is how much work are we doing in the soil testing that happens on agricultural fields before it runs off? So Nate, you want to come to the...
Yeah. So most of our work is, you know, in the surface water, but we do have a history of looking at, you know, the soils, and soil stratification is, you know, a big sort of question right now. How important is stratification in these fields? Ohio Department of Agriculture is looking at that, and they've put out calls for grants to you know, research to look at that. And so, yes, understanding what's happening on the field and how these nutrients are, being cycled through the soil and ultimately out to these rivers is really important, right? Understanding the watershed will help us understand the lake.
Some of the agronomy people are actually applying fertilizer on a grid.
Sure.
So,
correct.
Yep.
no more, no less.
Right.
So that's.
So Luann, coming back is so many of you probably know in the room for the crops that are primarily grown in Northwest Ohio, corn, wheat, and soybean, there's what's called a tri-state fertilizer recommendation. So they're saying you want to have enough phosphorus between this low number and this high number. We are seeing more and more research come out suggesting that that high bar that we said you can go up to this much, if you add any more, you're just wasting money on that fertilizer because it's not growing any more plants. We're seeing more and more data say that we can be applying at the lower range of that. And I'm not going to spout the numbers off here, but you got a low and a high number. It's called the maintenance range, kind of in there. All the data coming back says apply lower, because even if you miss a year, if it's too wet, you can't get out in your field and you can't apply those fertilizers. There's already enough there. And so to come back to your point, Luann, is also our farmers are now doing a lot of what's called variable rate application. Not only is it just soil tests and that's the number we pick, but there's a different low number for each one of those ports of that field. And so we're having very much progress in the application space. And if you look at the data, the sales of commercial fertilizers are coming down through time. And also the soil tests are also, those numbers are coming down, right? And so if we're not applying and the plants are taking it up every year, those numbers are creeping down. So those are those measures of success. And soil testing and variable rate technology were practices that were incentivized under the Governor H2 Ohio that the legislature has put back in again. Good question. Subsurface application is another one, and those sorts of things that are going on. So these are all great questions. I do have one more from the media that I want to make sure we get to. So Randy Edwards, freelance. Nate, this is primarily going to come to you, but the question is, and it was partially answered in your presentation, does particulate P end up in the sediments? Can it eventually become DRP? So when we say that 8% of that particulate phosphorus is part of the bioavailable because it actually makes it into the lake. But those sediments that sink in the Maumee, is that phosphorus then not in the equation anymore? Or will it, or could it become DRP? Come to you.
Yes, it can be. The sediments under certain conditions can release phosphorus into the water. Under the right conditions, they can absorb more phosphorus, right? And so understanding sort of what those conditions are, is it something that we can sort of recreate to make our sediment in the rivers and in the lake bottoms more of a sink, right? Absorbing more of that phosphorus, is definitely an area to explore, and is being explored. So yes, some of that does then become dissolved phosphorus eventually under the right conditions. Good.
Just add, one of the things we're looking at is
Projector points, we
one
can a little bit
of the things we'll be looking at for some of the variations between years that we don't quite account for is that phosphorus release. So there are some physical explanations that potentially can be modeled that we might be able to forecast some of that. So we're trying to pin that down. That's not a major factor in the system, but it is one that can have a bigger effect in a more local, so to speak, local environment.
We have Dr. Jim Hood in the room from Ohio State University. You're doing a lot of work in that sediments and the phosphorus that's in the bottom of the streams or also on the stream banks, what we call the riparian. So can you give a look into that? And then Justin, if you can be prepared, we got a nitrogen question that's going to come next on toxicity. So Jim, any thoughts in this space?
So we've been measuring phosphorus that is attached to sediments within the rivers and trying to understand the role it plays in either contributing to dissolved reactive phosphorus exports to Lake Erie or mitigating those. And what we and Becky Kreiling at the USGS and others are seeing is that overall, when we measure those, the sediments tend to be a sink, but it's also very difficult to scale those up. So I think we'll have to wait until more information comes in.
And some of that work that Jim and his team are doing is funded by the Ohio Department of Higher Education's Harmful Algal Bloom Research Initiative. So there's some great work going on there. The next question that I have, again, coming from the media, and then I think that's the last for now, and then I'll kind of open it up. But Randy Edwards, again, freelance, if nitrogen concentrations contribute to potential toxicity, are we measuring nitrogen levels as well? So is Justin in the room? Good. And so thumbs up from measuring nitrogen levels as well as the phosphorus levels. But Justin, you're also leading a HABS forecast model. Can you come up and just talk a little bit about that? Because many of you that have joined us on these calls frequently, phosphorus does help drive the blooms, but you add nitrogen, it increases the bloom, and then also nitrogen drives toxicity. So Justin, please.
So was there a particular question about
Just, I want to talk
toxicity
about
of
the
nitrogen?
forecast and where you're sitting in that space.
Oh, okay, so the forecast for microcystin concentration, which is still in development, it's not going to be like what we see here. It's going to be more of a short-term, week-to-week forecast. It depends on remote sensing to see where the bloom is. It depends on grab samples being collected on a Monday, analyzed that same day or the next day by NOAA researchers. And then if you know how much toxins are in your grab samples, how much biomass is in your grab samples, then you can do the math to look at the bloom spatial pattern and to see, you can estimate where the microcystins are. Okay, so you can make a map of microcystins. And then if you put that map of microcystins into the same water current model that moves biomass around, you can move those toxins around. So it's a short-term forecast that is still in development, still in testing, but it relies on grab samples, people on boats, grabbing water samples, and remote sensing. And then the part about the nitrogen concentrations in the lake are very high, June and July. Those drop through August into September. Most of the blooms out there early year are producing a lot of microcystins because there's a lot of nitrogen in the water. As nitrogen declines, the blooms are able to produce less microcystins because depending on content, about 14% of the microcystin is nitrogen.
Good. Thank you, Justin. But that does come back to the earlier question about our monitoring again, right? So for the in-progress forecast for toxins requires you to be in the water, taking grab samples and processing those back in a lab. Important question there.
I'll just add that
Project to please.
the forecast Justin's referring and developing when that's completed, we will implement it as part of our forecast system. So it'll be incorporated inherently into that. So we're looking forward to their final results.
Good. For those of you that did register, you just got it 3 minutes ago. So at noon, the official NOAA HABS forecast went out. So go tell your friends you heard it 15 minutes earlier from Rick because you joined the webinar. But that's officially out. So the links you saw on Rick's website, you can get to that forecast now. Answered a little bit in your question. These were things that were submitted beforehand. But do you want to talk about how this late rain in June might affect the forecast? You've said that July, low probability, but can you talk about June's contribution to the size of a bloom relative to something in March, April, May?
It's covered. We've incorporated the June rain that we had in the discharge is incorporated into what we have now. We're good with all of that.
And so, but would you say that in some of the years that were maybe the same amount of load, if more of that load came in June versus April, what is the impact of that on your model?
It appears that very high loads in July, late June and July, do have a bigger impact on the bloom than ones that come in earlier. But that's like 2015, 2019, and those were also really large blooms. But it does matter. But under a normal year, there's generally very low loads in July. So, and this is what we consider a very typical year. So I can't emphasize enough that the fact that it may rain doesn't mean that the forecast changes. We've incorporated typical June, July rainfall is already incorporated.
Thanks for that, Rick. I will look around the room. I've got a couple more questions here, but I'll look around the room. If there's another question or two out there, wait on you and I'll come here, Paul, to you. What do you got?
I think I have kind of a layman's question, actually. Rick, you actually mentioned the Detroit River a little bit as where you're talking about the distribution of the bloom. Can you make any assumption at this point about what the distribution will look like, or maybe the architecture of the bloom, maybe what areas might be more highly impacted in the Western basin than others, or is that sort of left up to chance kind of as the season progresses?
So I'll repeat the question, Paul. Thank you for that. So the question is there any ability for us to kind of predict where that bloom gets moved when it forms, and what kind of role does the Detroit River play in that bloom? Rick, I can turn to you, and then I'm happy to try too if you don't.
Yeah. Well, we can say the blooms start in the mouth of the Maumee River area. After that, it's very dependent on prevailing winds. We have started looking at the wind forecasts. And I don't know, for those who do weather forecasts, winds are considered very difficult. But usually when people talk about forecasting winds as being difficult, it's, well, what's the wind going to be on Sunday? And we're not asking that question. In our case, because the wind pushes the water around, so it doesn't matter if the front came through on Saturday or Sunday or Monday, it pushes all the water this way or that way. The overall patterns are, if we have a wind out of southwest, it tends to go around the Detroit River plume towards Canada. If it's a northwest wind, it tends to hit Ohio. If it's an east wind, it tends to go back to Michigan. And so we are looking at these 35-day forecast models, and to determine, we are starting to evaluate how reliable they are on doing that distribution. So we're hoping we can start getting to forecasts of the tendency for the bloom to be in one area or another, or the tendency for it to be scummy, or also to last. And that's one of the efforts we've started on recently, to see if we can get better to that. Right now, I can't tell you which direction it will go.
The Detroit in general will push it to the south part of the lake, but then around from there it'll move. I saw a bunch of other hands come up. Let's see. Mike, please come on up, Mike. Or you want, okay.
Undoubtedly, the Maumee is the major concern. But both you and Nate mentioned the total phosphorus loading in Detroit being substantial. It's not brought into the model though, in terms of the contributions of peak in the Detroit River, Lake St. Clair, which is Lake Huron, how that contributes to the blooms, maybe sustenance.
So the question coming in for Rick is, we know that the Detroit is basically half the load and the Maumee is less than that, but it's highly concentrated. Does the model incorporate that Detroit River contribution? So Rick, please.
We have a model that we've been testing that does include, basically includes the Detroit River implicitly. There are some models that do it explicitly. The key part there is Detroit River has low concentrations of the phosphorus, and at those concentrations don't favor development of cyanobacteria bloom. What they do change is kind of the background level, or they set the background level. So getting that Detroit River is important from that point of view. But in general, if the Maumee were reduced, the concentrations from the Detroit River aren't going to do it. As a whole different story, if you talk about the low oxygen area in the Central Basin, that's where the Detroit River becomes significant. But for the Western Basin, it's a very subtle impact, and because it's so low, it's not that important.
Tom Bridgman, I'm coming to you with a question.
So contributing smaller blooms over the last several years to decreased river flow, and mostly decreased river flow in general. I'm wondering how much of that decreased river flow might be attributed to best management practices on the water such as wetland installation and features designed to hold water versus just reduce precipitation.
Right. So Tom's question is, you'll see decreased phosphorus with decreased discharge, although we're seeing success below even those low discharge years. But Tom's question is, we've been doing a lot of things. Farmers, one of the incentives for there is drainage water control structures. Cover crops we know hold moisture. And of course, under the DNR, under the leadership of Eric Sauce and Janice Kearns with Director Mertz, the wetlands are holding some of that water. So any thoughts from folks here? I don't know if we've actually done the science to tie that reduction, but it's an interesting point to think about.
Yeah, my comment on that would be that, it's a possibility. Like there may be some effect to that, but when we look at precipitation numbers, I mean, the discharge follows the precipitation pretty closely. And so any effects of actual like water retention, is possible. But we don't know yet sort of what the scale of that would even really look like. So that's something, you know, somebody wants to write a grant. I think that would be an interesting study.
There's an aspect.
Wait till you get up here.
There's an aspect to this, though, that depending on the timing of those high precip events, like March, April, which you had mentioned, if you have wetlands or cover crops or that sort of thing, it may alter the amount of phosphorus or particulates coming in. So precipitation March, April is different than precipitation in May, June. But if you start adding in wetlands or other things, that can alter what a March, April load of phosphorus load might be.
Yeah, and I would, but one way to maybe get at that would be to look at hysteresis patterns in these rivers. Look at, you know, are we shifting when in that flow pattern the nutrients are being transported? It can tell us how far away those nutrients are coming, sort of what the flow paths are. And so that may be one way to get at, you know, are water control structures helping essentially slow that down and shift that load, you know, to later in the, you know, in the hydrograph, you know, to that falling limb side of things. So that may be a way to sort of understand that. Yeah.
We'll go one more here and then we'll switch over to our next speaker and then we'll reopen up for questions again. So if you didn't get your one and in this session, we'll come back, please.
There's a big push for Lucas for cleaning out the drainage ditches and assessing residents for the first time. We have a big meeting about it. We'll pay on our property tax. Is that going to affect it? They're really going to clear out the tributaries very far down.
So
We're on the river. And if it's a loaded one.
No, it's not. So the question is, just to come back to those that are online, the question is, there is a lot of maintenance that happens in our ditches that run along our river, right? We are farming in the Great Black Swamp. And to be able to farm in a swamp, you have to have drain tiles to drain those fields, and you've got ditches to move that water away. I will say first cut for me, but I welcome others up to the microphone. There's some great work coming out of Ohio State University that is looking at what do we do with those when we dip those ditches or take that out. We're actually seeing that if you put that back up on the agricultural field, you'll see a yield bump. You will see your crops actually use the nutrients that are in those sediments. So I would say anytime you disturb the ground, you're going to be moving sediment and potentially nutrients, but we shouldn't be thinking of that material as waste material. There is a use for that material that we're pulling out of those drain ditches. Sometimes that might elevate the cost because it's just easier to pick it up and drop it a little bit away from the ditch. If you can actually spread that on the fields, we're seeing some good information coming from that. Nate, did you have anything else?
Just one thing that we do see with that is the channelization of those ditches, you know, hardening of them if they, you know, cement them essentially. We see an increase in flashiness, essentially how quickly rivers react to rainfall events, increasing the flashiness of the smaller rivers. So things like, you know, Honey Creek and some of these smaller tributaries, Shallow Run, Potato Run. We don't see a huge effect at sort of main stem, you know, the Maumee itself, basically because that river's so big and so slow to react. But at the local scale, right, we do see a big effect in essentially how fast those nutrients can get transported, you know, off the field and then out of the system. You know.
And just to add a little bit more to that, there is work looking at what are called, you know, self-forming streams or two-stage ditches. So the historic just trapezoidal ditch on the side of the road, if we can make those wider, those rivers will bend naturally and they'll start creating a flow pattern of their own. When you do a two-stage ditch is where you have a kind of a stream bed, but then a bank so almost a secondary level. When you have heavy rain events, those phosphorus and sediments will collect on those banks. So there's a lot of stuff going on in these drain ditches and on agricultural fields to slow the movement of water and more mimic Mother Nature.
Other things that H2 Ohio.
And those are things that H2 Ohio has funded, and we've done some research with Ohio Department of Higher Education. So I'm going to call up our next speaker. You guys are released for maybe 15 minutes, but you're going to come back up again. Think of other questions, but we're going to have David Kennedy come up next. So let me shut down this PowerPoint real quick. David told me that he only has 130 slides, so we're good. No issues there. No issues there. We have students leaving the room. We had a bunch that joined us for the first hour. That's fantastic. Thank you, students. They don't care about humans. They just want to know the loading. Yes, yeah. No. You just want to know how our ecosystem is doing. Looking at Alex. Alex, we got to share screen. I'm going to turn your laser pointer on. Shows yours.
All right.
Dr. David Kennedy.
Thank you very much. So what I'd like to do for the next 2 to 3 hours is take you through some data, great painstaking detail. So I have a new title I just want to share with everybody. I'm also a grandpa. So this this is a new one, so I'm super excited. And it really kind of gets to the point of what we're talking about, which is human health, and having kids and grandkids who want to enjoy the lakes and the rivers, and both Lake Erie and inland, et cetera. And this is a picture that kind of drives home things for me. So courtesy of Dave Ruck. This is up in Monroe, Michigan. And just people on the beach during an active bloom. And let's see if this sign here is warning people to stay out of the water, or at least that there's the presence of a bloom. So this drives home a lot to us about the people who are living, working, recreating around the lake, and wanting to protect their health and do things on a number of different levels. So I'm going to talk about those today. So one of the things that we think about, and these are my PowerPoint skills. So please, Rick, don't critique that this is my bloom activity, but the primary culprit or cyanobacteria we call microcystis, starts as we just talked about June, July, and goes out into the fall. And there's a toxin that produces called microcystin. There's also some other what we call bioactive molecules called annabinopectins. And that's sort of the pattern that we see, and this is what we think about a lot in terms of Lake Erie. And slide will advance here. What we're seeing though is that on the lakes, especially the western basin of Lake Erie, there's presence of other cyanobacteria, Dolichospermum, or what used to be called Annabina, and they produce a whole host of other toxins that you see listed there. So in addition to microcystin, saxitoxin, anatoxin, again, some of those annabinopectins and cylindrospermopsin. And the interesting thing about these is that they've kind of extended the harmful algal bloom season, because a lot of those are cold resistant. So from and then this is just data looking just down the road from us down in Grand Lake St. Mary's, and they have a persistent hab nearly year round. So I just want to briefly go over this to make the point. Habs are big and they're complex. Like, there's lots of things going on, and from the human health point of view, we try to think about all those complexities. The toxins and metabolites and things that they produce, and then how that impacts human health. So how do we do that? And one of the ways we're really happy that we have the Great Lakes Center for Freshwaters and Human Health. And this is it's called a program project grant sponsored by NIH and NSF. And it's a consortium of a number of universities. You see their logos here. The first 5 years was led out of Bowling Green State University. It's moved up to University of Michigan, and University of Toledo helps co-lead this. And we think about the lake and what's being produced in a number of different projects. So what you see down at the bottom are the different projects and the teams that are looking at this. And I'm going to go through some of those projects today, just some, very high level highlights. But I like to think about it as essentially studying the lake from the bottom to the top, especially how the toxins and metabolites that these cyanobacteria produce eventually make it not just into water, but also out of the water into aerosols, and then how humans interact with that. So one of the first things, and before I do anything else, I'm really sorry. I should just want to thank the people in the room who are here. Is Justin? I don't know if Justin Chafin Justin is here. Tom Bridgman at the Lake Erie Center has helped a lot. Alex and Steve in the back who have helped a ton with this work. There's a number of other people from our community engagement corps, Chris Winslow, Sarah Geyer, and I'm sorry if I'm missing anybody else. But anyhow, this is a really collaborative effort, and it helps us to understand something that is gigantic and complex. And one of the things here, so in this first project of this Great Lakes Center that Justin helps lead, what you can see is that up here, they essentially do experiments everywhere from small little 2-liter bottles out to these larger mesocosms. You may have seen some on your way over today. This is a big 2,000 liter mesocosm, and then also the out in the lake, and they're taking those samples. And this group has been able to show a lot of really interesting things. One of those things is that when they go out here and they sample on the lake, they look at the ability for the different nutrients, nitrogen and phosphorus, to produce toxin, which is one of the things obviously that we're interested in. And what you can see here just at a high level is that toxin peaks early in the season. So it's higher early in the season, it tails off lower in the season. There's variability in between. And one of the things that this group has shown is that this is a graph of cloud cover, and that part of the variability and why things kind of peak up and down in between the high and the low spots has to do with the availability of light and cloud cover. This is what's called a benthic cyanohab bloom called Microcirrus. So this is actually benthic. It's just the bottom or the ground of the lake. So that's picking up a big rake and scraping that up off the bottom. So one of the kinds of cyanobacteria that we study. Another really interesting thing that this project does is to look at what's called the microbiome. So what you're seeing here are what a bloom scum looks like, but we take this and we can grow this up in cultures or little agar plates, and we can see the communities of bacteria, fungus, and other things that tag along with this. And why is that important? It's important because just like anything, the environment that you live in kind of determines a lot of your behavior. So in this project, what they've shown, I think this is really cool and beautiful. What you're looking at here is what's called a scanning electron micrograph image of microcystis. These are these little balls here, and what you can see here are bacteria that actually kind of wrap around and there we go, or along for the ride. You can see this here again. This is just a light image. You can see the bacteria and other things around this colony of microcystis, and I just think that's so beautiful and interesting, and one of the powerful tools that we have to understand this. And by looking at this, we can understand how do those bacteria think about if you have a neighbor who's annoying, right, and agitates you, right, versus a neighbor that's not annoying, and that how these cyanobacteria behave, the toxins that cyanotoxins that they're going to spit out is determined a lot by that. So that's one of the things that we're looking at. In project 2, again, we are looking at how do we
kind of assay all of the different cyanotoxins. I talked about microcystin and aminopeptins and things like that, but there's a lot of them. It's very complex. I talked about those two different species, Microcystis and Dolichospermum, who kind of live out in the lake. So one of the things we do is we assay the genes from these bloom-forming cyanobacteria to determine which genes are responsible for producing the different cyanotoxins. And we found that the environment, again, like we talked about that microbiome, that microenvironment, but also the environment that occurs, nutrients, weather, et cetera, temperature, it impacts the kinds of toxins and bioactive molecules that those complex blooms produce. So we try to understand that and model that. And obviously it's complex. These toxins don't occur just by themselves. They occur together. So we try to understand in a very thoughtful way, but also a high throughput way, how do these toxins behave? When are they occurring? What makes them occur? And then what do they do? What do they do to a kidney? What do they do to a liver? What do they do to a lung? So that's, again, just high level overview of some of the work that's going on. One of the things that we really rely on is having a facility core that helps us to process all of these samples. So we use a lot of high-end instrumentation called mass spectrometry to identify all of these different toxins. And this is, not just in the Western Basin of Lake Erie, but all over. And this is really important because we need to, not only be able to characterize what we're doing, so we know the toxin that we're dealing with. But then, if you think about it, if we find a certain kind of toxin that's out in the lake, well, if I want to do an assay with it back in the lab, I need it, right? I need enough of it, and I need enough of it to be pure so I can do that assay. So we have a facility core that also not only characterizes the toxins that are out there, but helps to synthesize them so that I can have a pure compound to go back to the lab and figure out what it does in the human body. And this is another, just to kind of give you the scale of what's going on and how the facility core helps. One of the things that proceeded from I would say the first generation of the center was what was called a HAB grab, where we went out onto the lake. This is listed some of the universities out there, but this was a really large effort, private industry, universities, agencies, et cetera. And what you're looking at is a heat map of the Western Basin of Lake Erie. And the different kinds I talked about, that toxin microcystin. So this is if you look at these colors here, the yellows and the greens and the blues, this is kind of the gradient of how those toxins are produced and the concentration over the Western Basin of Lake Erie. So in these HAB grabs, the teams go out in over a day or two simultaneously. Take water samples, and then those all come back to the facility core for analysis. And then what you're seeing here overlaid on top of that toxin map is a distribution of the kinds of one of those cyanotoxins I talked about, microcystin. So you can see that, this is complex. So microcystin, has higher concentrations here closer to the shore than out here. But then also, if you look here, what you can see is, the different congeners, what we call the flavors of microcystin, change throughout the lake. So you can look at those concentrations there. So this is really, really instructive for us, because we know that not all of those different flavors of microcystin impact the human health in the same way. This work would not be possible at all without having the ability to go out and do this, and the funding that we get through the center. Then here's another interesting thing. Again, we talk a lot about microcystin. That's very well known. But this is another. Microcystin has 7 amino acids. There's another what we call bioactive metabolite, aminopeptins, that has 1 fewer amino acid. And this is the concentration of these. And what's interesting is that, microcystin gets a lot of attention concentrations of anabinopeptins are sometimes orders of magnitude even higher than microcystins. And again, you can see here the heat map showing that the general, the concentration of these, closer to Maumee Bay. Then it goes out to the Western Basin. And then these are the different, again, flavors of anabinopeptins. And so you can see that, this is, there's a lot of, diversity in the kinds of toxins. So this really helps us to model and understand these. One of the other things that we've done, you saw sort of on the way in, what we're trying to do in terms of aerosolization. So we have a couple of projects working together, also with NOAA, to understand, okay, how do all these things get, into the air? Do they get into the air? Who gets into the air? Who stays in the water? And how do we determine that? And so we have some high volume samplers. We have samplers that we put out on boats. Again, we characterize and study the kinds of toxins that are coming out. And then what we have back in the lab is the ability to go in and understand in actual human cells how these toxins, we can aerosolize them in the lab and put them onto different cell types, particularly human lung cells, and understand if we take cells from healthy individuals who donate them or from asthmatic individuals, what's the difference? How do they respond differently to those different toxins? So this is out at our Lake Erie Center. We have a field station out here. This is I would call the prototype of the glamper that you saw coming in. And we go out all year long. So this is, we sample all year long, especially when there's ice coverage. We had a lot of good ice coverage this year. So that helps us to have a negative control, understand what's not there. This is a lot of fun, to go out there and freeze your knuckles off in January. And then again, our new and improved glamper, that you've seen out there. And we're happy to give some tours on the way out. So, what are we finding? This is data from last year. So what you're looking at are 2 days in August. So August 8th and August 14th. And, Rick and Nate alluded to this, blooms move, right? They don't always stay in the same area. And this is a little washed out, but what you can see is that the scum, that the surface scum, was not present in this location on the 8th. A few days later, on the 14th, it moved in. And as we look at the filters that we take from those days, you can see there's a filter from the 8th, and you can see how much more material is deposited when those blooms move in. Again, this was taken on September 9th, when the scum had kind of moved out with the wind. Then the wind pushes it back into the bay a few days later on the 11th. That's what things look like on the 9th. That's what things look like on the 11th. So we have some indication that at least the mass of material that's coming off when the blooms or the scums are present is a lot greater. And what we're working on now is taking these filters, parsing them out, and understanding what comes off the lake. I would be remiss if I did not talk about our human community health studies. So this is super important. When we talk about human health, the center this round funds 200 patients or participants from the Western Basin of Lake Erie, so that we can understand and measure what's going on in people who live, work, and recreate in Lake Erie and the Western Basin. And we're from those people, we're taking, if they consent to it, blood samples, urine samples. We collect breath samples. We measure lung function. And we take biopsied cells so that we can go back to the lab and understand what's happening to human health. We also have a mobile health unit that we take around. So we have a couple of mobile locations out at our Lake Erie Center in Oregon, Ohio, and most recently in Port Clinton, who's been generous enough to host us there. I will, please let me give everyone one of these flyers. I have them out, in our Glamper. So if you know anyone who's interested in participating, we're happy to have them, in the study. So, I now just do a little bit of a dive into what's going on and what we know. And again, I apologize. Some of this you've heard before, some of it you may not. But one of the things that we do is we look at public health data. And CDC captured some data from 2016 to 2018. And this is where people, when they have an event, are reporting. So about 3/4 are presenting to a poison control center. About 16% go to their healthcare provider on an outpatient basis, and about 9 or 10% go to an emergency room. So over this 3-year period, about 389 cases that, and again, this is self-reported data from the CDC. And what do these people come in for? Gastrointestinal symptoms, headache, fever, lethargy, some dermatologic symptoms, cardiopulmonary symptoms, et cetera. So it's a wide range of things. I can talk about that a little bit later, maybe in the Q&A session. But one of the things that we wanted to do, because we could get some really good high quality data from the emergency rooms, is we went into emergency department data, because when they come into the emergency department, they get coded with this is a billing code that helps us understand what a patient came in for, what they were treated for, and the symptoms that they had, et cetera. So looking again within the patients who came in through the emergency room, we put together the data that comes across the country. And this is the sort of the take-home message here, is that one of the things that we were really surprised about was that 1/3 of the people who were coming into the ER reported a respiratory symptom as their primary illness. And over half of the patients who were coming in through the ER had some sort of a respiratory symptom. About 27% smoke, which is a little bit higher than the average in the US. So that kind of keyed us in. And this was interesting because we actually see and take care of patients after they've been exposed to harmful algal blooms. This is a report that we just put in. And this is just a particular patient. She was a 7-year-old girl who came in, and I'm not going to go into the gory details of this, but really just to say that she had pre-existing asthma. And after swimming in Maumee Bay during one of the blooms, her asthma was exacerbated to the point where she needed to be intubated, and had a very long, complicated stay in our medical center, but did make a recovery in about a month. But what was interesting about this was that there were some clues here about the kind of asthma and how the asthma progressed, that made sense with the cyanotoxins that we're looking at and how they interact with the lungs. So why might respiratory conditions such as asthma be a concern? Well, we live in what's called the asthma belt. So there's a Midwestern asthma, Ohio Lake Erie asthma belt. And there's also one that runs along the East Coast. This is data from 2018 from the Asthma and Allergy Foundation of America. And Toledo, you can see, was number 2 in the asthma controller medication use, and number 1 in terms of quick relief medication use back in 2018. And interestingly, this is the most recent data that we have. We've moved into number 1 in both categories. So in terms of the medications, it's one way of understanding how controlled or uncontrolled asthma is in the population. And this is important because there's these little channels or doorways called organic anion transporting proteins. And those are the gateway for these cyanotoxins to come into cells. And if you look, this is data from a few hundred patients, looking at the expression of these channels in the airways of asthmatic individuals. So this is either in their central airways or their peripheral airways. And what you can see is that patients with asthma have 2 to 3 times higher numbers of these doorways for cyanotoxins to get in. And this is sure microcystins use these, but also aminopeptins use these as well. So we know that aerosols can be produced by wave breaking and bubble bursting. We also know from work from Andy Alt's group that aerosols can travel at least 30 kilometers from the source. So we really wanted to understand is, how do these aerosol toxins impact, lungs? So how do you model this experimentally? This is Vivek Tumasina. He's a PhD candidate. I talked about this Expo Cube, our tip of the hat to people, our friends from Canada. This is actually, the system is made up in Canada. I began to question a little bit the conflict of interest since these were mass produced during, or not mass produced, but produced during the wildfires. And I was like, I don't know, is this, the aerosols and the aerosol equipment. But this is how we, that was supposed to be a joke. I'm just teasing to our Canadian friends. We love them. So anyhow, this is how we take aerosols and study them in the lab. And one of the things I mentioned that we do is we take biopsies from patients, and we grow those cells up, not just in a dish of media, but we actually grow them up in what's called an air-liquid interface. So they actually live and behave like real pulmonary lung cells. And this is a picture of those cells here. So what you can see is that these cells have cilia. So all the lining of your respiratory tract has cilia that helps move mucus. You have the cells that actually produce mucus. Those are called goblet cells here. And so here's the top, here's the bottom. So they get nutrients from the bottom, and then we can expose the aerosols on the top. And one of the things that we did is we took cells from patients who were either did not have asthma or did have asthma, and we exposed them to one of those cyanotoxins. And what you can see is there's in healthy patients here, which are in the green bars, there's an increase in these inflammatory markers in those lung cells after exposure to aerosolized cyanotoxins, microcystin. But that bump becomes even greater in patients when we take cells from patients with asthma. So again, this was sort of a clue into us, and one of the things that we're working on actively to understand why that is. What about some other models of susceptibility? We'll just briefly go over gut and liver. So essentially, when microcystin hits a liver cell, a normal healthy liver cell is able to detoxify that and to make a product what's called microcystin cysteine, and a liver cell is able to survive. But if you have a liver cell that comes from someone with diabetes or non-alcoholic fatty liver disease, and you expose that cell to a toxin like microcystin, they're not able to detoxify the microcystin and produce that microcystin cysteine, and you end up getting liver injury and cell death. And so one of the things that we've done is try to look for and have found two different antioxidants that are able to help in that setting of diabetes and non-alcoholic fatty liver disease, to help push that and promote that detoxification over to that microcystin cysteine and improve cell survival in the liver in the liver. So again, just very high level overview, but just want to give you sort of the how we think about this and what we're trying to do to solve the problem. Also in inflammatory bowel disease, this is a model that we have where if you expose a gut to this is a mouse model that we have of inflammatory bowel disease, and what you're looking at here is an inflammatory marker. This is called TNF alpha. What you can see is that this increases in inflammatory bowel disease. When you take a normal healthy mouse and expose it to microcystin, there's really not a lot of inflammation that occurs in the gut. But when you add that exposure of microcystin to inflammatory bowel disease, what you can see is not a 1 + 1 = 2, it's like a 1 + 1 = 3. And you see an exacerbation, and that occurs for a number of different inflammatory markers. And so that addition of inflammatory bowel disease and exposure to these toxins is synergistic. And it creates one of these susceptible conditions that we're interested in helping to create treatments for. So the take-home message is that, you know, there's some common diseases such as inflammatory bowel disease, diabetes, asthma that may increase susceptibility to have toxins. What are we doing about this? Is it all doom and gloom? Well, one of the things that we know is that you know, this is from the CDC, medical care is supportive. There's no diagnostic tests, et cetera. So it's a real pain in the neck to, you know, if you think about it, it's like a process of elimination when a patient comes in to understand, you know, what is it that you're suffering from? Is it from, you know, something from a harmful algal bloom or something else? So our goal is to get to help physicians and healthcare providers make that determination a lot quicker. One of the things that we've done is developed, again, this is work from Dr. Dragana Salovic and Judy Westrick, who helped with our facility core, to develop a test for blood, urine, and plasma, so that we can actually detect the toxin in those and potentially offer this as a diagnostic when a patient comes in. But what if the patient comes in several weeks or months after the exposure? Which is one of the questions that was posed to us by our chair of pediatrics, Dr. Deepa Mukundan. She said, you know, sometimes people are coming in and it's weeks or months afterwards. What do we do if the toxin is now cleared from the blood? You know, how can we understand the impacts? So we came up with a way to actually measure an antibody response. So this is sort of like the signature that's left behind after the toxin is present. So those two tests that we have now, we have this community health study. We'll be able to go into those biobanks and start to test these and see, okay, you know, we know that this works in the lab. Are these also sensitive and specific to help detect toxins in humans? And then the last thing that I'll just end with is our really proud of the work. So, you know, we talk about the community. One of the communities that needs to be educated about this is the healthcare community. This is our pediatrics group at the University of Toledo, and they did a really fantastic job. What we have there is what's called the simulation center. So medical students, residents, faculty members can be trained into how to respond appropriately to different situations. So this was work supported through the Ohio Department of Higher Education, the HABRI funding. And what we did, so this is our simulation center here. So you're looking at it from the control room here into the you know, one-way glass. So we can look at and run our medical students and our residents through these scenarios so that they can help to learn to diagnose and treat exposure. So this was our first group. We ran about 60 of our pediatric residents through this. This is really exciting. We run them through a dermatologic workup, and then we also had a critical care workup for pulmonary distress. Again, this is a lot based on the experience that we've had at the medical center. So trying to equip healthcare providers with the knowledge of how to you know, deal with these. So again, key take-home messages. I think I'm just gonna you know, sum up by saying, obviously, these toxins affect a lot of our organs across the body. We need to get the word out in terms of awareness. We're not interested in scaring people, but it's about raising awareness, especially in vulnerable populations. And we're really interested in you know, moving the needle and providing healthcare providers with the evidence-based medicine that they need to treat patients who are exposed to these toxins. And I'm gonna first say thank you to all these you know, funders, but then also just leave this up. Again, I'll give you a flyer on the way out, but any awareness that we can bring to this study is great. So happy to take your question.
Good. Thank you, Dr. Kennedy. We've got about 10 minutes left in the webinar, so I have not seen any current questions come in based on your talk yet. We'll field those as they come in, but if you want to sit right here in the front, I might call you up. I am going to come back and get to some of the questions we had from earlier, real quick on that one. We did get some questions originally about H2 Ohio and the budget in the state. We have seen some questions coming in asking about NOAA. And so, as I mentioned, we have Sean Corson here, and he's going to come up and field a couple of questions that came in here. So the two that I'm going to pose to Sean, if he could come on up, is how many NOAA staffers are working on HABS work this summer compared to 2024? And then also in that, there is a device called an ESP. So it's an environmental sample processor. So those aren't in the lake this year, but we're looking to see from NOAA, from Sean here, are there going to be other changes to NOAA's HAB monitoring, forecasting, and research this year? So if you could talk about the workforce this year and any changes you see in Lake Erie in the HABs monitoring.
Yeah, sure. Thanks, Chris.
Yep.
Appreciate it. So to address the initial question about workforce, over the course of the year, as you heard in the earlier presentations, everything associated with HABs is about partnerships. Not only do we have partnerships at the state level, the university level, but across NOAA. So my office, National Center for Coastal Ocean Science, partners with Sea Grant, partners with the Satellite Service, NOAA Satellite Service, partners with the NOAA Research. So Great Lakes Environmental Research Laboratory just up the way. All of us have been affected a little bit differently by some of the early retirements and some of the probationary employees who left earlier in the year. By and large, across those offices, we're down between 25 and 35%. So that does have some impacts on what we can do. Specifically, talking about the ESPs, this gets to Dave, a lot of your points is about toxicity. ESPs are devices that are moored arrays that are over in the western portion of the bay and can bring high frequency sampling to the weekly sampling that currently occurs for toxicity. As we're making adjustments to this summer to address some of those staffing challenges, the Great Lakes Environmental Research Laboratory decided to postpone deploying those in favor of the weekly sampling. With that said, NOAA is certainly committed to continuing HAB forecasting going forward into the future, advancing toxin forecasting. It's going to take us a year or so, a season or so to redistribute and work out how we're going to meet those challenges with a new workforce that we currently have. Some of these issues that Dave touched on in this talk recently are relevant here in Lake Erie, but also all over the country. So NCOS works with similar consortiums like this. It's got academic, federal, state, local consortiums in places like all along the eastern seaboard, the Gulf of America, the western coast, addressing things that are important to public health, to the coastal economy. These things can make the public sick. They can cause, unfortunately, mortality. Folks are hospitalized from these things around the country. Different species of HABs every year. We have these kind of events, and so we know how important it is to the public, and we're committed to continuing these HAB forecasts and toxic forecasts.
Thank you, Sean.
Yep.
I think we have a question in the audience here real quick, and then I have a couple more online for us before we close down.
So it's kind of a big question, but climate change will eventually accelerate the hydrologic cycle with more frequent and intense rainfall, which affects agricultural runoff. And according to a study, textbook, in the Midwest agricultural belt, climate change is likely to increase agricultural runoff to upwards to 19%. Also, it interferes with the carbon cycle, phytoplankton, photosynthesis, respiration, decomposition, and a multitude of other biotic processes. My question is that how have we seen or expect climate change to affect Lake Erie and its eutrophication, and how do you adjust for climate change?
Well, I'll take a crack at it. We're seeing some of those same things from the National Weather Center. The region of the Great Lakes, we should see about 11% increase in precipitation, and that's both snowfall and rainfall. And we're seeing elevated temperatures. And as we know, these organisms like it hot, right? They like that warm temperature. And so what we'll need to do is the things that we're deploying now, again, our wetlands and incentivizing farmer practices, water management is key, right? We always talk about how do we control nitrogen and phosphorus, but this isn't just a nutrient control. This is us thinking about water management. And so the question that came out earlier about our drainage ditches, and when we go and dip those and clean them out, we really, really have to think about how water moves across the landscape. And as far as in the lake, I'm going to look to our limnologists in the room. When you see that earlier temperature, that means that our blooms are showing up earlier and maybe staying around late. But you got to remember the amount of phosphorus that's in the lake for them is also being then just consumed earlier and late. We need more data on this, but what we see is that even if the bloom starts earlier and stays later, you still have a limited phosphorus out there. So it seems what happens then is the bloom shows up earlier, but it doesn't peak as high as it peaks normally in August. So we're watching it. I'm looking at the Tom Bridgmans and the Justin Chaffins in the room and others. I mean, it's something we got to be watching. We are going to be farming, living, doing the things we do in a different context, in a wetter, warmer place. And we're just going to have to track these blooms through time as those changes manifest. Anybody in the room, raise a hand, come up to the microphone, want to weigh in on that one? Justin's shaking his head. No, that's good. I'm always looking for approval from Justin. That helps me out tremendously. There was a question that did come in about legacy and current phosphorus. So for those of you that aren't in this space as much as many of us in the room, legacy basically is referring to phosphorus that wasn't applied during the fall or the spring, more importantly, the spring before planting season. So is it phosphorus that's already in the fields that is contributing most to the runoff that happens from 1 March to end of July? Or is it the activity and the use of that fertilizer in the later fall or in the spring? Work out of USDA ARS, Kevin King, Will Osterholtz in that group has shown that it's 2 times more phosphorus can be tied back to that old phosphorus in that March to July window. Okay. Now, when we call it old phosphorus, all we can really do now is tell you that it was applied 120 days ago. Right? We can't figure out whether it was been a decade in the field, 4 decades in the field or not. Right now, old phosphorus is about 120 days after its application. So we are seeing that. What I will say is that we've done great work with the ag and the ag community and producers to work on the right rate, the right placement, when to put down their fertilizer and all that kind of stuff. But what it tells us is that if we're going to lower the nutrients running off the landscape into the Maumee, into the river, or into the lake ultimately that drive these blooms, we have to be deploying solutions in the old phosphorus space. And that's where things like phosphorus absorption at the edge of field, wetlands, there are things called modified blind inlets that farmers can put into their fields. We need to think more about trapping stuff that's already there, in addition to the incentives that we're giving to farmers to help them apply it in real time. We got about 3 minutes late, so I'm going to look down here and see if there's one more question that we can get in that makes sense for someone. David, I'm not seeing any health questions. Their minds are probably still spinning. What's that? Where at? I'm not seeing them on my refreshed. Okay, I only see the one. It says the bioavailable phosphorus in the Maumee has reduced 5 to 10% since roughly 2008. Is it fair to say we're only 10 to 25% of the way to the 40% reduction? That doesn't seem like a David Kennedy question. Yep, so it's not updating. Try and send that to me again. We will send some of these questions to David because we're not going to have a lot of time to get to David's here today. Let me see if that updated. Oh, okay. So I got it now. Recent research from UT found HAB toxins in beach sands. Can you talk about that possible exposure route? Have you seen what is called four sands? Sure. So when the waves crash up on the beach, they don't go all the way back. They do soak into that sand. That's where we build our castles, and the sand is wet. That's called foreshore sand. We have detected toxins in there. Can you talk about that potential exposure route? We got about 2 minutes left.
Yeah, so I'll just say we have an active project going on, one of the with our dermatology group and one of the graduate students in our lab, Ben French, who's looking at dermal routes of exposure. So that would be the most likely from the foreshore sands. Usually intact, healthy skin is good enough at protecting from toxins. When you have similar to what we see in other things, if you have a break in the skin barrier, or if you have conditions like atopic dermatitis, that break down that barrier, that's when we, think that we are going to see increased impacts. But I'm really excited. Actually, Ben's has data that's coming out right now, where we're going to be looking at the actual transmission across the skin in both healthy and disease states. So stay tuned. We'll have some good information on that soon.
Good. Thank you for that. Yeah, Tom, real quick.
Just refers to a study that was done on Maumee Bay State Park Beach.
Good.
And found that toxins can persist in the sand for several days at least after the blue is very hard to wash it away.
Good.
So it's very highly variable. Find that their toxins can persist in the sand for at least several days.
Good. So Tom's response, Tom Bridgman, Dr. Bridgman from UT. So a study actually found those toxins in the sand, and you do not need to have the bloom present at that beach for those toxins still to persist in the sand. And then David did talk about the possible exposure routes if those toxins are in the sand into the human body. We are at 1 o'clock, and so we're going to shut down the webinar. For those of you in your room, if you have any other questions, we'll take those. I just want to thank, number one, all of our speakers today. That's phenomenal. Yes, round of applause. And I want to thank again, this room, we would not be able to make the progress that we've made, although maybe we want it to happen quicker and sooner. We would not have been able to make the progress that we've seen. We're seeing these 5 to 10% reductions despite flow. If it wasn't for the state and federal agencies in the room, the state and federal elected folks in the room, and the academic institutions. And I love looking around for those of you online. There are a lot of students in the room that were blinking in and blinking out and walking on here. It's awesome to see that our academic institutions are training that next generation of scientists, and they have a want to be in this room and to be part of that solution. So thanks to that. And I do want to call out NCOS and the Stone Lab Sea Grant family, because I get to stand up here and do all the talking, but there's so much movement behind the scenes that happens. So thanks for Jill and Alex sitting in the room. I know Aaron and Lily are back watching virtually, and many others at the NCOS office. So thanks. This is an all hands on deck. Many hands make for a light load, but thank you for joining us. I'm about 1 minute over, so I will shut down the webinar. Please look for the recording, pass it along, and we will try and get a lot of duplicate questions on here, which is great, but we'll try and get some answers to some of those and get them posted up with the webinar. Everybody have a great day.